Got the first Q&A for maths methods. This question is about the normal approximation to the binomial distribution. So starting with the question, given the probability of success is 80%, assuming a normal distribution, determine the number of trials for there to be a probability of 40% certainty for at least 220 trials to be successful. So pause the video, have a go at the question, and then we'll look at the solution. So the question is initially a binomial question because it talks about probability of success being 80%. The fact that we have 220 trials means that we're probably not going to use this manual formula unless we're after just 0 or 1 successes. So we can ignore that and think about these other ones. So yeah, it looks like a binomial question, but it says assuming a normal distribution. So this is what a binomial distribution normally looks like. We want to approximate it with a normal distribution, okay, knowing that the mean and the variance or the standard deviation we can calculate. And normally there's some conditions to be able to do this. I think NP and N1 minus P both have to be greater than 5. But in our situation, we can just assume it's a normal condition, so we can assume these conditions are fine. We just need to calculate the mean and the standard deviation, and we're good to go. So that's probably where you came into trouble, that you know probability of success is 0.8, but N, you have no idea what that is, but that's okay. So our mean is NP, which is N times 0.8, okay, so 0.8N, that's fine. We can deal with that, and our variance will be N times 0.8 times 1 minus 0.8. Okay, so effectively we'll get 0.16n for the variance, so my standard deviation will be square root of 0.16n. I can do something fancy here and say it's 0.4 root n, but I'm not going to bother doing that, just to make the calculator work a bit easier in the future. So effectively we're in this situation now where we want at least 220 successes, and we want this area to be 0.4. So our job in this case is to find n. So if we open normal CDF, okay, we really want something from 220 to some big number. Normally just 6 nines is enough for infinity. Okay, but we don't know the mean, don't know the standard deviation. That's fine. We're just going to put 0.8m and square root of 0.16m in there. Okay, and we want all of this to equal 0.4. So we've got options. We can just guess and check values of m for the number of trials. Probably won't be that efficient, probably won't have time to do that in our exam, or we can use nsolve. So effectively we're going to get the calculator to guess and check values of m for us. Okay, so nsolve means, hey, solve this equation for me by guessing and checking values of m. Okay, so go ahead, put that in your calculator, and you'll probably get a domain error. Okay, so what that means is that something weird happened with your guesses and it couldn't evaluate normal CDF, so we just need to change this m to give it a better guess. So let's start at guess at, say, 220. So let's change the last little bit to start at guess at 220, which hopefully should give it a solution. So we've got m equals 272.9. Okay, remember n is a n or m, whichever letter you're using, is a number of trials. Okay, so we'll round this up to 273 trials. Okay, if you wanted to check whether that solution's right, you can go back to your normal CDF and say, yep, lower bound 220, upper bound huge, make your mean 0.8 times 273, and make your standard deviation square root of 0.16 times 273, and when you just enter that in, you should get approximately 0.4 as your probability. Okay, so it's a pretty hard problem, but utilize the power of your graphics calculator to either guess and check by yourself or use the whatever numerical solving ability it has to solve the problem for you. All right, good luck. And if you have any other questions, feel free to ask them on that Facebook group.